Welcome back to another video in our DREAM3D-NX tutorial series. In this video, we will demonstrate how to segment EBSD data while preserving large unindexed areas and removing small unindexed points. The first thing we will do is import our CTF data into DREAM3D-NX. We'll drag in the file, and the Read Oxford Instruments EBSD data filter will immediately be brought in and assign the file as the input file. Then we'll name our image geometry object the same as the file name V1034. This dataset does not require a crystal reference frame rotation, but a sample reference frame rotation is required, so we'll add the Rotate Sample Reference Frame filter. Set the rotation to 180 degrees about the 0, 1, 0 axis and assign the image geometry as the V1034 data object. Next, we'll need a multi-threshold objects filter. Apply the error object to the path parameter, then filter out anything equal to 0, then change the mask type to unsigned 8-bit integer. Now we'll need a compute IPF colors filter. For this filter, all we need to do is populate the required paths. Ensure you enable Use Mask Array and use the mask object for this path. Now we can run this pipeline and address the results. We'll switch the data view to 2D image slice and the color array to view the IPF colors object. Now we have an initial look at our data. Let's do some further filtering and processing. Let's add the Replace Element attributes with Neighbor filter. Here, we will change the threshold value to 0.1, then fill in the paths for the input cell data parameters. Quick note, you can right-click a filter in the pipeline and click Filter Help. This will bring up the filter documentation on our website. Another note, enabling the hover cells on option in the visualization will allow you to view individual cells in the data just by hovering over them. Now let's run this pipeline again with the newly added filters and view the changes. We have removed the isolated, unindexed pixels. Now we'll need a Convert Orientation Representation filter. We'll need to change the output orientation type to quaternions and fill in the input path. We'll also name our output orientation quats. Next, we'll add a segment features filter specifically with the misorientation. Enable Randomize Feature IDs and use Mask Array, then populate the 5 required path parameters. Once that is done, we can rerun the pipeline and view our feature IDs in the visualization. We'll change our color array from IPF colors to feature IDs. We can also rescale the color map to a certain range that we want. Let's set a minimum of 0 and a maximum of 1. The large unindexed areas are easily seen with this color contrast. Now we'll need a Fill Bad data filter. The minimum allowed defect size for this dataset is 750. We'll populate the paths, then run this pipeline again. Now the smaller areas have been filtered out and we're left with just the large unindexed areas. Here is a before and after of this change. Now we'll add some additional filters to calculate the feature sizes, phases, and average orientations. First, the Compute Feature Sizes filter. For this filter, we're populating the 3 required paths. Then for the Compute Feature Phases filter, we'll fill in the phases, feature IDs, and feature attribute matrix paths. Lastly, we'll need the Compute Feature Average Orientations filter. We'll populate the cell feature IDs, cell phases, cell quaternions, crystal structures, and feature attribute matrix. Now we can add a Write DREAM3D-NX file filter to save our pipeline data. Finally, we'll add a Write ASCII data filter. We'll add the path we want to save our output data to, then we'll add equivalent diameters, num elements, and volumes objects to export. Run the pipeline with these added filters to save your DREAM3D-NX file and ASCII data. Thank you for watching this tutorial in DREAM3D-NX. If you would like to learn more or try DREAM3D-NX, please visit our website at dream3d.io. Please leave a like for future DREAM3D-NX tutorials and subscribe for notifications on new videos.